Hello, my name is Mark Fennell, and today I'm going to talk to you about the fundamental properties and motions of electromagnetic energy. What I'm going to talk about today is really an overview of everything that's going to come in my subsequent videos, as well as being the first chapter in my book on electromagnetic energy. What I'm really going to talk about is going to come in the form of lists, specific bullet points. And while these seem to be just little points, they're actually very valuable. I have become a really strong expert in electromagnetic energy. I've made discoveries that no one else has yet made. And these points that I make are the real essence, the real character, the real properties of what electromagnetic energy really is. So pay attention to these pearls of wisdom. To begin with, what is electromagnetic energy? Is it a particle? Is it a wave? Is it a photon? Is it a blur? At its central core, electromagnetic energy is a ball. It is a sphere of energy, a region in which electrical fields and magnetic fields are traveling within. So here's first number point. The essence of electromagnetic energy is a definitive single object flying through space with its unique properties. It contains electric energy and magnetic energy. Now we get to the second point. One of the main properties of electromagnetic energy is that it flies through the air like a baseball. You take a baseball, you throw it. That's exactly how a photon is. When you emit a photon from a transmission antenna, you're in fact sending that baseball through the air. And just as a baseball will fly through the air until it is caught or hit with a bat, the same thing happens with electromagnetic energy. That photon will fly straight through the air in a single direction until it is either absorbed or deflected. So again, the second point on electromagnetic energy. Every burst of electromagnetic energy is like a baseball. When it is emitted, it is a single object traveling through the air in one direction. It can be caught, that is absorbed, or it can be deflected. Now this is the classic understanding of electromagnetic energy that was first understood by Newton and was also further developed by Einstein. Now we're going to get to something that nobody knows, and I'm the first to discover, is that electromagnetic energy pulsates like a heartbeat. Now people like Maxwell discovered that electromagnetic energy is a wave, and we use that for FM radio and so forth. But really it is not a wave, and I'll explain that later. The main motion is it's a pulsation, like a heart. Pulse, 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 pulse. So while we have this baseball that's flying through the air, it's also pulsing at the same time. I have three analogies for this, and it leads you deeper and deeper in understanding. The first analogy is the heartbeat. It pulses. And like different animals have different heartbeat rates, the same thing with electromagnetic energy. There are different bursts that have different rates of pulsation. The second, more deeper understanding of pulsation is the actual direction. And in this, it expands like a balloon. It becomes this oval shape. Expands up, contracts. Expands down, contracts. Expands up, contracts. Expands down, and contracts. So it very much looks like a balloon. Except where a balloon is filled with air, our balloon is actually filled with electromagnetic energy. The energy is expanding and contracting, expanding and contracting. The third analogy, which goes into deeper understanding, is what I call the hand-woven bag. Electromagnetic energy very much looks like a hand-woven bag, where the yarn are the energy strings of our photon. And you can stretch our bag and compress it. You can stretch our bag and compress it. And that's exactly what the pulsation is like for our electromagnetic energy. So again, a major point about electromagnetic energy is it pulsates like a heartbeat. Or it is like a balloon, which expands up, contracts, expands down, and contracts. Every burst has a unique pulsation frequency, just as every animal has a specific heart frequency. Now the next motion, I think you'll like this, is what I call the pizza dough. Every burst of electromagnetic energy actually comes in a cluster of bursts, and they spread out. And this is exactly like pizza dough. You take pizza dough, you clump it together in a ball. Clump it, smash it together. And then what you do is you roll it out. Roll it, roll it, roll it, make it into this wonderful 12-inch pizza pie. If you've seen some of the professionals do it, they'll toss it into the air, spin it with their hands, and as they spin it, it'll get wider and wider and wider and wider. Well, that's the exact same thing that happens with electromagnetic energy. Electromagnetic energy is almost never emitted as a single burst. It's usually emitted as a clump, just like our pizza dough. And then we have our magic pizza maker who spins it. So as the electromagnetic energy clump is being sent into the air, it spins and it becomes wider and wider and wider and wider, always in this even pizza dough pattern. So this next operation of electromagnetic energy is it acts like pizza dough. Starts as a clump, then it rolls out and spreads out into a nice even pizza pie circle as it travels throughout space. And again, here's the summary. Starts as a pizza dough clump, travels out, spreads evenly thin, makes our 12-inch pizza pie, 30-inch pizza pie, extending out a mile, 2 miles, 10 miles, ever getting thinner, but always a circular pizza pie. The last trait of electromagnetic energy is something that is very important, and it is another one of my fundamental discoveries. People love to say that electromagnetic energy is a wave. There's often the shorthand, people talk of radio waves. Well, I am here to tell you today that electromagnetic energy is not a wave. It is not a wave. It's a nice shorthand way of looking at it, but it's not a wave. The analogy I like to use is Mars. Mars is a planet, but it travels in an ellipse. Shall we say that Mars is an ellipse? No. Mars is a planet that travels in an ellipse. That's a difference. The same thing with electromagnetic energy. Is electromagnetic energy a wave? No. It is not something that's smeared out in a wave pattern. It is a physical object. And it travels in a wave. It can be tracked as a wave. That is a very distinct difference. So again, electromagnetic energy is not a wave. It can be tracked as a wave, but is it in fact a sphere? Just as Mars is a planet, not an ellipse, we should say the photon is a burst of energy. It is not a wave. It can be tracked as a wave. And how it is tracked as a wave is one of my great discoveries. I'll present this in another video. And actually, through a series of videos, I will show how the particle is a wave. I will finally solve the riddle, is it a particle in a wave? How is it a particle in a wave? And I will provide for you the general principle of particle-wave duality that applies to photons, electrons, and many other objects in the universe. So again, what I'm talking to you about today is the main motions, the main characteristics of electromagnetic energy. These points are the main principles that are expanded throughout my book, throughout all my discoveries, throughout all the series of videos that we will discuss. Again, these main principles are: the central point of electromagnetic energy is it is a burst of energy. It is an object, a sphere, with electric strings and magnetic energy strings. That is what it is. Then this sphere can be thrown like a baseball. Straight path. Can be absorbed, can be deflected. It pulsates like a heartbeat, or like an expanding balloon that expands and contracts in different directions. It clumps as pizza dough, 1,000 bursts coming together, then rolled out and spread apart, thinner and thinner. And finally, it can be tracked as a wave, but it is not a wave. It is not some smeared energy. It is a sphere that travels in a wave faction. Those are the essential characteristics of electromagnetic radiation, electromagnetic energy. And that concludes today's video.